mechanism problem. So in this one, they tell us the first step is slow and the second step is fast. Great. When the first step is slow, you can just focus on that first step there, right? And the reaction mechanism is just going to be K times reactant times reactant. So K times A times B. Done. That's the easy kind. Now, what happens if we flip that around? What happens if the first step is fast and the second step is slow? How does that change things? Well, right away I can write out the rate laws. So let's see, right? The rate law for the slow step here is going to be rate is going to equal, I'll call that K2 times B times D. And like, yeah, so can we just stop there? Why can't we stop there? Because what's wrong with D? So I check B, B is a reactant, but D is made in one step and used up in another step. So that is an intermediate, and we can't have intermediates in our rate law. So once I write the rate law for the slow step, I realize there's an intermediate in there, and I have to solve for D in some way. So I go back and I look at step 1, and I say it's fast. That means the rate of that forward reaction equals the rate of the reverse reaction. So let's write that down. So I've got rate forward equals the rate reverse. And so the rate of the forward reaction is going to be K1 times A times B. We found that already in that first problem, right? So it's just K times reactant times reactant. Now when I reverse it, I'm going to call this K -1. Now I'm going in the opposite direction. And these are my reactants. I've got C and I have D. Now D is our special guy. You're such a special guy here. D is our intermediate. And so what we want to do is solve for D. I'm going to solve for D just by isolating D. So that's D. I'm going to divide by K -1 times C. And over here I've got K -1 times C. So that's what D equals. D equals all this stuff. I've got D, that's my intermediate, is equal to K1 over K -1. I'm going to end up combining all those constants anyway. A times B over C. That's what D is. I'm going to take all of that and plug it into the slow step. So when I do that, then I'll have just reactants, products, constants, anything that I need, and that'll be fine. So down here, I'm going to write, so this is rate 2. This is our slow step. Rate 2 is equal to K2 times B, right? I'm just getting that from here. This is we're calling rate 2. K2 times B, and then all of that D is getting put into there. I'm going to put it right down here. And that's going to be my K1 over K -1 times A times B over C. And now I can combine things to make that a little bit easier to read. I've got K times K times K. So I'm going to combine all those K's. Let's do it in a different color. All right, so I'm going to combine all these K's. That's just going to be a new K. A constant times a constant divided by a constant is just another constant. And then I've got B, A, B. All right, so I'm going to call that A times B squared all over C. And so that is the rate if the second step is slow and the first step is fast. So just one more time, how did we do that? We said we focused on the slow step first. We wrote the rate law for the slow step. Rate 2 is equal to K2 times B times D. Again, you're just focusing on the reactants. Constant times reactant. We recognize that D is an intermediate. We can't have intermediates in our experimental rate law. So we went back up to rate 1, step 1, and we said this is a fast reaction, means it reaches equilibrium fast. Equilibrium is when the rate of the forward reaction equals the rate of the reverse reaction. So I set those equal to each other, and then I solved for D. I just isolated D, so I have D times all this stuff divided by all this stuff. Over here, you get D, and then take that D and plug it into the slow step. So we're always going back. We start with the slow step, we end with the slow step. We just use that first one to solve for D in terms of things that are allowed in that in the rate law. And so that's where we got that one. So just again, to summarize one thing up here, if in general, whenever a fast step precedes a slow one. So if you have fast and then slow, you're going to have an intermediate. So that's, we're talking about this step in here. If you have a fast one and then a slow one, you'll have an intermediate and you have to solve for that intermediate.